Let's see. Let's see. Does everything work as intended? I think so. Uh, let's see. I'm just messing a bit around with the stream settings. I'm unsure whether this works. Seems like it. All right. So in the last episode of this series, I was pretty tired and ended up getting tilted by IntelliSense. I actually wrote the correct code, but IntelliSense didn't really register. Didn't really register things correctly. So yeah, I got a bit frustrated, but yeah, as you can see, the problem still exists, but I've done a bit of changes to the code. Since these libraries do get included in our PCH file, I won't be including them here, and I'll just have to live with the fact that IntelliSense doesn't really uh, register things correctly, but yeah, whatever. So today I will be continuing on the project. I'll be trying out streaming on both Twitch and YouTube. Was just wondering what category uh, uh, my stream got put under in on Twitch. Uh, hmm. I'll just mess around a bit with the settings and then I'll get going. Let's see. Mm, mm. If you're watching this on YouTube at a later time, you should really skip on till I start doing something, since I will be trying to let's see. I think I got it fixed now. All right. I think I got it right now. Yeah. All right. So no more fiddling around with the streaming for now, at least. Yeah. So last time I started by creating the renderer class. I also had to add the macro for importing or exporting our DLL. I forgot that. Yeah, I had an IntelliSense warning. Uh, yeah. Um, so yeah, that got changed. Uh, and as you can see, I made this component inherit from, instead of just typing com pointer and the DXGIFactory, I had to include the namespace, which was the cause of the errors in the last episode. But as you can see, IntelliSense doesn't really recognize the namespace. So yeah, that's where we're at right now. I added the using namespace specifier, or not specifier, but um, um, note here. So yeah, that is where we got to. We should probably continue onwards. Everything compiles, even though IntelliSense doesn't really recognize it. As you can see here, everything works fine. So yeah, uh, for some reason, IntelliSense lists 2,000 errors, but yeah, I chose to just show the build errors for now. Maybe IntelliSense will get things correct at a later point. So yeah, we started by creating the DXGIFactory last time, and um, I actually kind of forgot to make an overview of what DXGI is. Um, if you look it up at the documentation, DXGI is a Microsoft DirectX graphics infrastructure, and it's basically a part of the API that makes it possible to use DirectX. Yeah, so it's really low level and close to the drivers, and handles different parts of uh, the communication with the actual hardware. So yeah, that's why we have to use it to be able to run DirectX 12 upon it. So yeah, um, this example is with the DirectX 10, but yeah, as you can see, even future graphics components is able to use it, are able to use it. Sorry. Yeah. So we need a factory, and actually, the last time we did a um, a call to create the factory. As I've said, this version of create factory allows you to specify a debug flag. For whatever reason, when I use factory 1, sometimes the debug DLL doesn't get loaded. So yeah, that's why I've changed to use the create DXGIFactory 2. If you specify null here, or rather, if you want to use the macro, this should compile and work fine, but you won't be sure that the DLL for the debugging interface gets loaded. So yeah, let's see. Yeah. So for some reason, the com pointer should have the pointer. It did really work last time. Let's see. Let's see. Yeah, now IntelliSense woke up, and everything seems to be somewhat working. Um, mm, let's just rebuild this. Nope. I have to look up whether it's part of a namespace. I actually can't remember. And if we try to use that in our CPP file, does anything change? Nope. Let's see. Let's check the output. So yeah, we have a linker error. Let's see. Is it a part of a specific namespace? Let's see. Yeah. We of course have to include the .lib file. Yeah, everything works. Yeah. So, as we talked about in the last episode, we can look up the different H result values. Here are the definitions. So we could test whether this function fails or whether it works as intended. So let's just do that for now. Do some simple debugging. I won't prioritize doing a debugging interface. So for now we will just use simple debugging. Let's see. Yeah. And we can also just make sure. Let's see. All right, something. Yeah, of course. Now I know what's wrong. We haven't actually implemented creating a factory yet. So, yeah. I changed a part of our renderer code between last episode and this one because, yeah, I ended up messing around with the whole IntelliSense situation. So yeah, I actually ended up trying out a lot of different things before I realized that my first intuition was correct. So yeah, lesson learned. Don't always trust IntelliSense. Just write whatever you think is correct and try to compile it before you change it. Um, yeah, so we will try to create a factory. Um, yeah, so as you can see, the factory gets created correctly. Um, we would like to throw some kind of error. So usually I use macros for that. Um, and maybe we should do some macros. So let's just create a new header file and call it helpers. And um, we already included the standard IO. I'm unsure whether we actually want to use that because I would rather use the IO output stream. I can never recall the header for that one. For some reason. Let's see. IO stream. It should be correct, but yeah. And we will include our helpers. This should also actually work since we've included the directories. Yeah. for some reason, IntelliSense is really not helping out today. Yeah. So now we create a macro called yeah, maybe we should do it only during debug mode. Let's see. Yeah, I would like a debug version and let's see. Oops. Yeah, I would like a debug version. Oh. Let's see. Yeah. Let's define a debug print. Let's see. Whoops. I have caps lock on. Yeah. So this should compile fine. So now we can let's see, this should not be needed. Yeah, everything should be working fine. So debug print should be fine now. Everything okay. All caps lock because I'm almost a boomer. Oh, we have a syntax error. Yeah, of course we need the streaming operators. Yeah. So now everything okay. So now we can just do basic basic macros if we want to print something during debug. And we of course have to make sure that whenever we aren't in debug mode, we will just ignore that so we don't get a compilation error. Now everything should be working fine. Yeah. If we don't do this, I think we will have a compiler error. Yeah. All right. We also want some sort of macro to handle our assertions. Maybe we should use the assert. Yeah, so we could use assert. We could do that. Mm. Hmm. For now, I'm not sure whether we want to throw no matter what. I'm not sure whether I think we would like to throw an exception or abort the program if um, creating any of these low-level components fails. So I'm just gonna define a macro. Uh, which is yeah, which handles the checking whether we got this result after a call to the API of DXGI and also DirectX. Yeah, I think that would be a good idea. Hmm. Yeah, because I would like to throw an exception. I would also like to know where the error happened and perhaps do a bit of error parsing. Yeah. First, I think I would like to define a print macro that does the exact same as the debug print. Uh, maybe we should just call printm so that we can always change the format here. Should be fine. Yeah. Um, and then we should define a function that is called something like GXE evaluate, because that is our naming convention of our DLL. And we would like to evaluate perhaps an H result, and we would like to yeah, let's just look up macros line file. Let's see. let's change this to a print normal define print file and line. Let's see. File line message. Error add file line message error code. Let's just do message because we can pass in the actual message. Yeah. So now we can check if X is unlike is okay. And if that's the case, we should print fl file line test. Let's see. So if we try to wrap our H result in that macro, let's just save it for now. And let's see, that should be it. Yeah, we know that everything works, so if we just skip this, change this, I mean, yeah, error at file, blah blah blah, message test. Yeah. And let's see, does this actually work? I'm not sure. It does. So we could add H result is, and I'm unsure whether it gets 0. Let's just try to force some of the handle that is not valued. Well, yeah, maybe we should change the macro later on, because yeah, for now we aren't running into problems, but we might eventually. Let's see. We would like to throw an exception. I'm unsure whether the throw call. Let's see. The throw exception expression. We could throw x. Let's see. Yeah. Now we at least get an error message and we throw an exception. Maybe we want to add a bit of formatting because uh, because it gets pretty unreadable. Eventually we would like a more sophisticated logger, but for now this will do. So yeah. For now this will do. Yeah. And of course we only need to throw an exception if we aren't getting an OK message. So now we can evaluate the H result of all our calls to the DXGI and DirectX API. And we create a factory. Whenever we instantiate one of these factories. Local variable not initialized. Oh my god. Yeah. Let's see. Perhaps. I'm actually unsure whether we need the macro for our factory. Let's see. At least it compiles. Yeah, I'm actually unsure whether that is needed. The last time IntelliSense actually complained about it not being there for the renderer class. Yeah, I think it's because when the application starts, we actually create an object on the application object, and perhaps it needs to export those kind of different declarations and definitions, but it probably doesn't need to do that for the more internal stuff of our DLL. Okay. So now we got our factory during our during our initialization. The next steps are to create a an adapter, a device, and eventually a swap chain. before we can render anything to our window, which is right now just a window with nothing in it. But yeah, I've actually decided that I want to do a debugging interface. For now, and for that we will be creating a new class that runs our debugging API. Let's just call it xdebug because it's DirectX debugging. We could also call it DXGIFactory. Yeah, probably a better name because we started creating, or rather calling our factories DXGI. So yeah, let's do that. Okay. Let's see. So the debugging library is let's I just have to look up where the all right. So the component is called the debug interface, and as you can see, whenever we call enable debug layer on this component, we enable the debug layer. I'll be showing more of the way we get debug information, but it's really useful when we get further along and start to interact with the DirectX components, because we will get an output in our output list that shows clearly what error message we're getting from the API, and without it we can end up being somewhat blind. Yeah, I just have to. I'm unsure whether the header, which is referenced here, is included in the main header for DirectX, which we include here. Let's see. It's a rather long header, so we might as well just test it out. So yeah, we will be using a com pointer again as a smart pointer for our, let's see, as a smart pointer for is it that caps? Yeah. Okay. As our handler for reference counting and so forth. We also like to create a static class, since we only need one debugger and we would like to be able to reference it wherever we are in our application. So let's create a method that we call get for later use. We also create a static debug pointer called static instance, which will hold our pointer to our reference of the instance. We would also like to delete a copy constructor. We would also like to delete the copy assigned operator, since we don't want to copy the static instance. It doesn't make any sense. So yeah, we would also like to be able to know whether the debug layer is actually enabled. And we have to move these files. Yes, here we go. Let's see. Oh, I once again forgot the namespace. You will probably end up seeing me doing that a lot. Let's see, let's just create the namespace here. So yeah, so now we have our class laid out. Next we will implement the definitions. Let's see. Let's create some definitions. Let's return that. And we declare a global variable. Let's see. Debug pointer. Let's see. Let's see. Let's get a pointer instead. Oh yeah. Oh yeah. The problem with doing that is because whenever you reference a COM pointer, you end up getting a subclass that doesn't really yeah, maybe we should just actually change this into just, since it's itself is a pointer, maybe we could do like that. Let's see. Let's see, a private constructor as well, perhaps. Maybe just a default. Let's see, yeah. What do we end up doing? Yeah. So we should return a reference, I think. Let's just see. This might not work, but it does. So now whenever we call our debug get, we get the static instance of this one. Since it's already a pointer, we just want to pass the actual reference to the pointer. It might wrap it into a COM pointer reference. It usually, or sometimes it does that, but we can always just use the functions on that object to get the underlying pointers. So that shouldn't be a problem. But yeah. I actually think that I'm gonna do a short break, and this also allows us to slice the YouTube videos as a more separate video on a limited topic. So yeah, I'll be uh, doing a somewhat short break and be continuing on later on with the next step in our series. Hopefully I'll see you around. Bye bye.